While we wait for caller mic, let me welcome everybody who is here and just point out that this is a watershed moment in the history of INSA for two reasons. One is the public private partnership, which is so graciously provided by SRM University. So, I mean, just look at this very vibrant hall. A whole lot of INSA meetings are 50 fellows listening to each other. And so, of course, we know that fellows don't listen to each other. So that the young people here are going to be beneficiary of all the great deep scientific talks that we have lined up here. The second aspect of this meeting, which is very unique for the first time, is that we recognize people here, the scientists, who are not only produce science and write papers, but also people, the other stakeholders of science, who provide leadership in science, who have provided the use of science to create socio-economic opportunities. So these are the two unique features of this particular AGM of INSA. Sustainable development, which as I point out is an oxymoron, so which basically means we'll never get there. Second, the rise of intelligent machines, and so it's going to impact every aspect of our life, and it is impacting. And then going from invention to innovation, and innovation working together. Yesterday I was in IIT Bombay, and they had a Murti of Saraswati. And we know all of these gatherings, we invoke Saraswati. So there is a Murti, there is a photo of Saraswati, and I pointed out that we also need a Murti of Lakshmi next to it. So this is not to show any disrespect to Saraswati, but the fact is that Saraswati and Lakshmi have to work together for each other's good. And so to make that particular transition from academia, so to have that DNA in academia. And the second thing is diversity, inclusion, and equity. What are the strengths and weaknesses of Indian science? What makes S&T work or not? Okay, this is not something that we understand in our labs as to what makes S&T work for us, for our industry, for our economy, for our society. And then finally, what is the kind of mind processes which are required in order to meet the challenges of the new era, which are sustainable development, intelligent machines, invention to innovation, diversity and inclusion. In this 10-year journey, something has happened, which is of course fueled by a whole lot of things. It is fueled by the rise of demography. So our strength is demography. The median age of the country is 28.2 years. The median age in China and USA is 38.2 years, which basically means that there is a great window of opportunity, which is all these people who are sitting here. They are the ones who are going to write the future, but this window of opportunity is open for another 30 years, after which the society starts graying just like everybody else, which means that more younger people have to support the graying population, which means it slows down the economy. And so, of course, other people, other societies and countries have found a way out. When you don't have young people, you let machines do the work of people. But our problem is entirely different. So our problem is how do we make use of same technology, same machines, but to create new opportunities, not to destroy jobs, not to substitute for people who are not there. So of course we have hugely diversified market and demand and new enabling policies and stuff, but with all that positive comes with the fact that while quantity is good, the quality is lacking. So depending on how we measure quality, there are many different ways to do it. But basically quality is lagging much behind quantity. The relevance and direction of research is not always clear because the inspiration for research in universities comes from somewhere else. It's not our problem. It's not India-centric problem. We understand very little of what the India-centric problems are and what the solutions are for them. The divide today between research is not between applied and basic. No, those things we have been debated for a very long time, and that's not really the point. The real conflict is between profound and incremental. No matter if I do basic research, no matter if I do applied research, do engineering, whatever. Are we leaders in that or are we followers? So that is a basic thing. Are we can we take risk? Are we connected to industry and society and so on? So these are the set of weaknesses in our science. It's not IQ, it is not training. The people in India can crack the toughest exam in the world that nobody, the great universities of the world, they cannot crack it. So it is not a problem of IQ, it's not a problem of training. So what is the problem? I think I would focus on that particular aspect that we do not often discuss. And that issue basically is cultural and behavioral. So what I would like to do is focus on cultural and behavioral aspects, not about what exams we crack, how great IIT people we produce, and so on. So when I was secretary, I used to hear these kind of questions every day, and I know Professor Saraswat here, everybody. Why one is a follower rather than a leader? Why one is risk averse? Why we are incremental? Why one is not connected to stakeholders of science and technology? Why one is negative and complaining all the time? Look, all of this stuff I'm saying from my experience. I know my colleagues in the top IITs, they sit in tea clubs for 3 hours a day. They bitch about everything. They say only if my head was different, if my dean was different, if my director was different, if the great leader was different, okay, then everything is going to be okay, right? But they are never talking about what is it that they are doing, right? So what is their contribution? And so this negativity actually is killing us. It has killed all the big institutes, all the great institutes of yesteryears. And so why one negative complaining all the time? Why there low self-esteem? Why there little translation and innovation? And then of course finally I put a smiley there. People ask, they say, why there is no Nobel Prize? Okay. And so if you ask 100 scientists, the only one answer they would provide is, the most frequent answer is funding. Now I got nothing against funding. I want a lot of funding, and funding is very necessary to do things, and we need infrastructure. But the question I'm asking is that sufficient? While that is necessary, is that sufficient? And so I'm saying there are many areas of science which do not require huge amount of funding. Theoretical sciences, for example. Are we leaders in that in the world? So therefore, my hypothesis is that funding alone is not, while necessary, is not sufficient for us to be leaders, to be disruptors, and all of that in the world of science. So, okay, what makes science and technology work? There is an invention ecosystem, invention and discovery ecosystem, which is all universities, R&D labs, and IITs and ISAs are part of that, which means it's a black box in which money and support comes in and knowledge goes out. So we produce knowledge. Hope is that this knowledge has relevance and direction, and that it connects to the stakeholders of science. There another ecosystem which we call innovation ecosystem, which another black box in which knowledge goes in and money comes out. So you see, invention and innovation are totally different ecosystems. The point is, can they work together? Is again back to Lakshmi Saraswati paradox. And so since our society in knowledge has been very Brahminical, so we say only Saraswati, okay, and we don't respect that particular aspect of them working together. So it is not our invention ecosystem which is weak. Our innovation ecosystem and connect between invention and innovation is weak. And a lot of this is now happening, which is making it stronger. Of course, we need right kind of policies for science and technology to work, and I'll give you an example of that later. That I will focus on cultural and behavioral aspects. So this is basically the roadmap of what I want to discuss quickly. Let us look at the overarching challenges of science. Now, no matter what kind of science I do, I call myself organic chemist, inorganic chemist. By the way, I'm not a chemist, I'm a chemical engineer. But people call themselves red chemist, green chemist, physical chemist, what have you, right? This is not about problem solving. This is about my tools. So I cannot take my tools too seriously. I have to focus on problem. And so sustainability and climate is one of those problems which is hugely interdisciplinary, and it's not only a problem of science and technology, it is a problem which has much larger dimensions. And so we must understand those larger dimensions. Of course, when we talk about any technology, we talk about nexus, we talk about life cycle, and in fact, finally, you have to ask the question: what is development? Okay, so now you see, while we have had green technologies for a long time, what does a green technology do? It basically reduces emission per GDP, but it does not reduce consumption. So if you were to look at emissions over the years, there is no let up. No matter what new technology one is going to put out there, you see emissions are always increasing. Okay, even in the COVID time, there is no let up. So the point is that while technology is important, it is not the only solution. And a whole lot of people hope against hope that by the end of this century, we would have 1.5 degrees Celsius temperature rise. But it's not rational to say that what I did for 50 years and yielded no result, doing the more of it for another 50 years is going to yield different results. That particular thing is called stupidity. Okay, and I guarantee you that in the end of this century, the temperature rise would be 3 degrees Celsius, not 1.5 degrees Celsius. Okay, so what does it mean? What it means, I often read this. It says, I used to think top environmental problems are biodiversity loss, ecosystem collapse, and climate change. I thought with 30 years of good science, we could address those problems. But he was wrong. The top environmental problems are selfishness, greed, and apathy. And to deal with those, we need a spiritual and cultural transformation. And we scientists don't know how to do that. Now, of course, what he's saying about scientists is true for everybody. In fact, it's hard-coded in biology that people have to be selfish in order to evolve, in order to compete and succeed. But there is something more to it. So he's saying all future challenges that mankind has are not merely of science and technology, but have very strong socio-cultural, psychological dimensions. Okay, so there's a whole lot of new movement in the world which says, how do we replace for-profit ecosystem which maximizes the profit in a very limited way for a particularly isolated entity, maybe even at the expense of society at large. So one has to think about a new paradigm of going from ownership to trusteeship, because sustainability is all about trusteeship. It's not about ownership. So there is something which has happened in the last 2 centuries, which basically says, look, the society thinks and works in a particular way, and I will come to it in a moment. Okay, the second overarching challenge is the rise of intelligent machines, which means the convergence of all the different streams of knowledge, communication, computing, computing at the edge, making autonomous decisions through AI, ML, making autonomous actions through actuators. You may call it Industry 4.0, IoT, whatever. It's all happening. So convergence between cyber, digital on one hand, and physical and machine and materials on the other hand. What is the next challenge? The next challenge is integrating biological into cyber-physical. So this is going to happen whether we like it or don't like it. Somehow biological would seep into cyber-physical, and a whole lot of cyber-physical will seep into biological. And so this is inevitable. It is happening now, and it's going to pick up pace. So now this one, of course, is about lights and shadows of technology. And what that means is, while we are very gung-ho, we are gaga about AI, ML, it's going to impact every aspect of our life, sometimes positively, sometimes negatively, and all of that. So there are lots of big concerns about the ethics. Does it amplify biases? Does it amplify inequalities? Does it undermine justice for certain sections of society? In fact, even the notion of democracy, okay, the notion of governance, all of that is going to be very seriously impacted by the rise of intelligent machines. So we have to be prepared for that. Now, of course, sustainability is about balancing invention which have relevance and direction and purpose, with innovations that consume that knowledge to produce new opportunities. So I call it the circle of knowledge. So sometimes you produce knowledge, then you consume knowledge, you produce opportunity, and you go back. There is no sustainability of knowledge unless invention and innovation work together. And so, when I often talk to younger people, by the way, it's my favorite thing that I tell younger people. I say there are no old people in this world. I am young and you are younger. And there are other people who are younger than you. Okay, so never ever make the mistake of asking people how old they are. Just be polite, just ask them what is your age, when were you born, right? There is no such word as old at all in this world. So take it out from the dictionary. So I tell younger people, look, there are 3 ways of solving a problem. This is what I call in Hindi, jugaad, dhanda and panga. Now we need, dhanda is basically business as usual, right? So business as usual is needed. 80% of society works on business as usual. But those problems which have very, very vexing dimensions like the ones that we are talking about, we need panga. We need whole lot of panga, and which means disruptive way of solving problems, which means not be resistant to change. Now, often it seems that any little change anybody proposes, there would be 10 people saying, but that's not how it was. Okay, so this capacity to change and to engineer change proactively is basically what is going to get us through. So out of box thinking, whatever you call it, but basic point is, hey, take risk, even if it means that there is some limited setback, there is some limited failure, if you would, but take a risk and find new solutions, some of which are going to work, some of which are not going to work, which is perfectly okay. As Hemingway in one of his books said, it's better to have loved and lost than not to have loved at all. So this is perfectly fine. Society as a whole is robust. It can take chances. There has to be reforms every 5-10 years in everything that we do. So here is about knowledge pyramid. Knowledge pyramid, okay, all for my younger friends and stuff, they say, look, it all starts with resources. That resources create data and measurements, which are dime a dozen now. It's exponential. So the data we have produced in last 2-3 years is an excess of produced in the entire history of mankind. And this is not going to stop. So therefore, what happens, we have data, measurements, we have to extract information from there which is useful. From that information, we must get knowledge. The knowledge is that matrix under which we can interpret things. For example, F equal to MA is knowledge. So a lot of information can be explained with the help of that knowledge. And the hope for humanity is that, look, we distill wisdom out of that knowledge, and that is the weak link right now, because every entity is self-centered. This is true of all government departments, it's true of all individuals, it's true of all scientists. So basically, idea is that, look, we are unable to go, we are stuck in information and knowledge, but wisdom is so important to solve all the problems that we would be facing, humanity on planet Earth, for all centuries to come, all millennia to come. So now, innovation is a reverse journey. One starts from wisdom, knowledge, information, data, measurements, and create money. So knowledge pyramid works in both ways, that one goes up and then one comes down, and this two-way journey basically is what makes science successful. Okay, another very important challenge is diversity, which is about equity, it's about inclusion, and so on. And I just give you some examples of what happens when there is no diversity. So you see, there was this great company called Kodak, which had 80% of all photography market, and they were the leaders of digital photography. But their top leadership, with a lot of experience, very wise people, they opined that there is no future for digital photography. There was another company which were leaders of personal computing and personal computers, and their top leadership opined that there is no future for personal computing and personal computers. Now, how do you think these people went horribly wrong? And in fact, the first one went down to business. right, is because they were not looking at the holistic picture of science, which means what is happening in the proximity of their science. To explain it, you see, digital photography will not succeed until you have personal computers and personal software like Windows. The personal computers will not succeed until you have digital applications you can run in your home. So both of these are co-dependent on each other, and if we do not see what is happening in the world around me, how my science is impacted by science being done by other people and other sectors, then we are going to fail. So of course, Nokia refused Android, Yahoo rejected Google. So basically, I come up with this idea. When a distinguished but elderly scientist says something is possible, she is always certainly right because it's based on his experience. However, when you go into uncharted domain, if somebody says something is impossible, it's probably wrong. So these are many lessons from the history. This is about being resistant to change. It's about learning new things. So just to give you an idea, I am a chemical engineer by training, but I have attended very few chemical engineering conferences. I have attended them if I am getting an award. But otherwise, why do I need to go there? Because I know chemical engineering, right? So I rather go to other kind of conferences that I do not know anything about. I borrow ideas from there. I understand what other people are doing and how this can enrich the work that I am doing. So creativity is all about connecting dots of knowledge which have not been connected before. This is very simple. If we want to be creative, we have to learn from outside and bring it in our domain. So here is, so we talk about what are the processes of doing good science. Now this is something, there have been a few technology missions of the government, the recent ones, supercomputing mission, quantum technology has just come up, cyber physical systems, all of them. So they have a very unique architecture and processes. And Dr. Saraswat has been the co-conspirator in all of these missions, in seeing them through. So what is it that we want? We want flexibility, we want arm's length from ministries, we want empowerment, so that, for example, the board of these, and Dr. Chris Gopalkrishnan is sitting here. He is the chairman of the Apex Committee of Cyber Physical Systems, right? So what is it? All the powers are basically delegated to this Apex Committee. They decide what is the vision for mission, what are the deliverables, who is going to do it, how they are going to do it, what is the allocation, and it's dynamic. So if somebody is not performing, do a Blade Runner, cut them. If something new is coming up, seed that, right? So that flexibility and that power has to be there with the scientist in order to do this. So all of these are, for example, Section 8 companies, the hubs and spoke model and spike model, as I call it. But basically, idea is, look, we need to have an end-to-end integration of scientific processes. What is that end-to-end integration? It means basic research, it means technology development, it means product development, it means funding startups, it means connecting with the industry, taking money from industry, but more importantly, giving money to industry. Okay, without that, it's not going to happen as a partnership. So all of these missions have that DNA. It means that basically all of this happening end-to-end way, and I think that this would be a template for all the future missions of the government. That flexibility, work with arm's length, make leadership possible in scientific community. Okay, so now about inclusion and diversity and all that. So you see, 50% of society are women. But let me tell you, in INSA there are 8% women fellows. Half of them are over 75. Age is another diversity. We don't, in Oriental societies, we don't value age. I mean, we just say, look, it just depends on how much hair I have and how much of it is gray. That tells me how wise I am. This is not true. If you look at, US, for example, most of the editors or the big journals would be in their 40s. Here, I have been an editor of an American Chemical Society journal for last 10 years, but I was 55 when I became that, right? And there, you see, so we need to balance energy with experience. Very shortly put, energy and experience have to go together. Every committee, everything must have this diversity of perspectives. So the diversity of age, gender are very important. In fact, I remember when I became fellow of INSA, I was rather young by the standards of INSA, when the average age of a newly inducted fellow is 59 and the average age of fellowship is 75. So when I became fellow, I was like 42, 43 or something like that. I got very lucky, but I was in the selection committee for fellows. Next year, Dr. Mashelkar, he had great trust in me, so he put me in the selectional committee. And I remember everybody else was over 60, right? And so I was arguing about matrices, I was arguing about some things which were new, and this person, little jokingly, he said, we don't take anybody below 50 seriously. Okay, so the point is that we miss out on connect with the world, because younger people are better connected with what is happening out there. See, if I want to find out a fellow who is very deeply into AI ML, I can only find maybe 2 people. Okay, because these are new areas which are coming up, which are very important, and unless we have that diversity in our organizations, they are not going to be very good. Okay, so now we talk about future and future of science, and people say, hey, what is waiting for us? What is our future? No matter what kind of scientist you are, no matter which industry you're going to work in. Basically, while we cannot predict which product would come, you can predict what kind of products will come. This is what the mind wants. So what are the needs of mind, of human mind? These are to be healthy, have quality of life, to be connected with equality, to learn, to make decisions in complexity. This is about AI, ML, to be entertained, maybe AR, VR. The life is nothing but a metaphorical entertainment. Everything we do has some entertainment value in it. I mean, I don't want to point out to this gathering, but I am saying, look, we are all social people. We want to be entertained, to have better life, to be happy, to have fulfillment, to connect. You know, the rise of social media is because in response to that particular need to create and control its own world, which is about, let's say, for example, AR, VR. Now I know we cannot control our spouse in real world, but in AR, VR, that is possible. Okay, and everything, you know, that you cannot do in real world is possible. To live long, maybe forever, this is about digital twins and so on. The very basic thing in which current civilization has gone horribly wrong is to equate happiness and fulfillment with consumption. This is the rise of Chicago School of Economics at the turn of the century. And today nobody questions this assumption. Okay, so we say, okay, you know, I've seen so many unhappy people, they say I only have 5 cars, but now two new cars I'm going to buy, they're going to make me happy. I know so many people who have, let's say, so many zeros in their bank account, and they're trying to figure, if I added 2 more zeros, I'm going to be happy. Nothing can be more misleading than that. Nothing, right? So now as scientists, we have to understand that there is a thing called Maslow's pyramid of hierarchical needs. And this I did in Psychology 101 back in 1978 in IIT Kanpur. And so there are 2 kinds of needs. These are called deficiency needs, roti, kapda, makan, safety needs, needs for esteem and so on. The deficiency needs can be addressed by science and technology very well. But then once there is a sufficient number of zeros in the bank account, the growth needs actually take over. And those needs are cognitive, aesthetic, actualization, transcendence, whatever that means. But we all know what it means, right? And the fact is that science and technology cannot address effectively these needs. In fact, they may be inversely correlated. So I know that, okay, people say, if only I added 10 more cars, I'll be happier, but it's just the contrary. Okay, so I see that they are more miserable the next day than they were before. Okay, so now this is about problem solving. Now, the purpose of science is problem solving. It is not to develop just tools. And so while we have plenty of departments everywhere, the departments are good for undergraduate teaching and giving a sense of identity, but they are not good for problem solving. So to my mind, everything we do in science is according to 4 M's, which are mechanics, understanding, materials, machine, devices, systems, manufacturing. No matter which department I belong to one of these things or several of them, and there are also meta super M's: markets, management, money, and men. So we often ignore these 4 M's and we are focusing on one of the 4 M's, which are of what we call science, but they are not enough. So there is also a compelling role for humanities and social science, and I wish that the more academies of science actually integrate this, because this is so required for problem solving. The final thing, I want to give an example of policy, saying how policy makes science and technology work or not. Now imagine, all of you know that the maps that we use are not Indian maps. They are not made in India maps. The data is ours. The people who make maps are sitting in Bangalore, Indian people. But the monetization is not done here. Okay, what do you think is the reason for that? The reason is policy. For 100 years from the time of British, there was a policy which says that nobody can do surveying and mapping in this country without very tedious approvals from defense, from home, from IB, from Survey of India, from what have you. So even for the government projects, it takes 8 months to get these clearances, and you can imagine the impact it has on economy and development. So they started looking at a new policy, because this domain, Survey of India, surveying and mapping, is a part of Department of Science and Technology. We start having a look at it. So while I don't have time to go into the total contours of this policy, you have to balance developmental needs with security needs. So there is always a conflict between the two, and how do you resolve that conflict? So if I were to put it in one sentence is that there is no approval needed for surveying and mapping by any Indian entity without sharing the data with somebody else at any scale, except in those areas which are declared out of bound by a competent authority. So it's very simple. Okay, take care of security needs in whichever way. You don't allow people to fly drones, you don't allow people to come in, that's fine. But the rest of the country has to develop, and for those developmental needs, we need these very good digital maps. We need to be able to fly drones with LiDAR. We need to be able to have also the eye in the sky working together from the ground all the way up there. And so the opportunities that this is creating, if you think this simple policy change, the impact on economy is not thousands of crores. It is not tens of thousands of crores. It is not 1 lakh of crores. It's tens of lakhs of crores. Very simple thing is, in addition to, of course, all this stuff which happens, you see, Swamitva scheme basically gives ownership certificate of land to people who don't have it, especially in rural areas. Which means, if you have no ownership certificate, you cannot monetize that land, you cannot go to a bank and take loan against it. But now that would be possible. Whole country is being mapped with an accuracy, with resolution of 10 centimeters. And this Swamitva scheme basically gives ownership certificate to people who don't have it, which means it's like, all the gold we have sitting in the bank doing nothing for us. So land has been locked economically. And so once that comes out in the economy, it's going to have huge impact on that. So anyway, I want to conclude by saying that in the last year, India had the presidentship of G20, and Science 20 was being handled by INSA, and we had these major themes: clean energy for greener future, universal and holistic health, and connecting science to society and culture. Now there were some recommendations which were accepted by all the G20 countries in their communique. By the way, that was a big achievement. because there were very few communiques of different groups in G20 which were universally accepted by all the member countries. So anyway, science is not that political, so it is possible to do it. So we said, look, there are lights and shadows of exponential technology, but nobody is in control. There is no global platform which is looking at the impact of these technologies. So should we have a global platform which integrates policymakers, government, organizations, academia, everybody on the same platform to do brainstorming on what is the impact, positive and negative, of these new technologies, which nobody has clear understanding of. There's nobody in control. So we need to do that. About the renewable clean energy transition, it has to be done with justice. What that means is clean energy transition will not succeed unless the last person out there is reached and is able to have access to renewable energy. So this is justice that goes with transition. So transition everybody talks about, but what about the justice? Okay, and then of course you have it. Okay, let me kind of summarize. What are the processes of new mind to meet new challenges of the humanity? Common sense, which is not common. Lateral thinking and connecting the dots, which is creativity. Being interdisciplinary is about problem solving. Tools and concepts that we develop are portable across the silos of knowledge. Synthesis rather than analysis. Now from my own education is basically going from chapter to chapter, and going from exam to exam, going from degree to degree, but there is no synthesis. Problem solving requires synthesis, not analysis. And so we are very weak in that, and starting from the school days, that has to be there. Innovation and startups catching on very big, which is very good. Relating a narrow domain of knowledge to larger concerns of science and society. These are the challenges and the processes of the new mind required. Shift from tool-centric to problem-centric. Not just say, I am organic, I'm something, I have a tool and I will find a problem that fits the tool. So that is the general approach in academia. But we have never defined a problem and say, I will develop the tools which are required in order to solve this problem. I totally understand that most of my colleagues would be very skeptical about what I'm saying, because this is now how business is done in the community. I totally understand that because I come from the same community. But we need to pay attention to these aspects very much. Okay, so finally I come to INSA because I'm a representative of INSA. So all the stuff I talked about, how do we translate that no matter which organization I belong to? All the stuff that we talk about, how do we translate that into action? That is the most important aspect. So I'll give you just some limited actions which are happening in INSA. So when we talk about policy, so we need to, globally, all the academies of science, they are policy think tanks. They basically US Academy of Science, Royal Society, everybody, people ask for their opinion. INSA is a collection of top minds of the country in science and technology. So we have to leverage that in order to give whatever advice which is sought. Okay, so we have started a new INSA Center for Science and Technology Policy. I'm happy to tell you that DST has supported about 1 crore for the first year in order to kick this off. And I want participation of each one of you, each INSA fellow, associate fellow, no matter by what name we are called. But we are saying, look, that we need to work on this. We need to produce all these white papers, the policy, the vision papers about what is happening in science and technology in the country. Hopefully somebody would listen to it. So it has to be also an advocacy group, which we are discussing yesterday, that there is no advocacy group for science and scientists in the country. We talk about diversity and inclusion. So, because age, diversity is missing in INSA. So we created new 2 categories of associate fellows, and they are called the young associates. So basically people below 40 and people below 50. So there is a spectrum of ages in INSA, which means there is new energy and new programs which can be driven through them. there is a lack of diversity of age, but also of gender. So we are starting a new vertical in INSA for women associates from all walks of life, all stakeholders of science, all ages, half of them from academia, other half from industry, startups, all of that. So they should have the role, they should take the lead into mentoring, into networking, in pushing women to the next level of excellence. There are new distinguished lectures in INSA. There are expanded opportunities. Number of fellows elected every year has gone up from 50 to 100. Because I said, look, there today compared to 20 years ago, there are twice as many scientific institutions and scientists who are working. So we must have recognition and opportunities for these people. Also, you realize that there are three major academic transitions that have to be managed. When people enroll for PhD, when they are new faculty or scientists, and when they want to switch to administration of science. So there are new courses in INSA, new programs in INSA, which basically prepare people for these transitions in academia. And okay, so that's the end of it. These are all my artwork. A lot of people appreciate this artwork. Then I ask them, do you want to buy it? They disappear. Okay, so at that positive note, I would close here, and I'm sure that we're going to enjoy. There are very compelling lectures which are coming up with the great domain experts and everything, and all of you are going to enjoy these interactions and these lectures. So please, all of you, stay on. Leaving is not an option here. Okay, so I stop there. Thank you very much.